If I put a mirror right next to me, the image on the other side will look something like this. Meet my twin. Hi, I'm Annie E, and today we are talking about light, color and sight with a focus on color and optical instruments. You can see yourself in a mirror because of reflection of light. The characteristics of an image formed in a plane mirror are virtual, upright, laterally inverted, the same size as the object, and the distance between the object and the image form is the same. But what about color? The color of an object is the color of the light that is reflected from the object into our eyes. The primary colors of light are red, blue, and green. The addition of these colored lights creates secondary colors. Let's look at this diagram and the following questions. The three primary colors are projected onto a white screen so they overlap each other. Question A. Name the colors of A, B, C, and D. In order to answer this question, you need to know the results of the addition of primary colors of light. Blue and green give you cyan. Blue and red give you magenta. And red and green give you yellow. A combination of all these colors will give you white light. So the answer is A is cyan, B is magenta, C is yellow, and D is white. The current screen used in this experiment is white. If it's changed to red, what are the colors seen in area A and B? Primary colors will only reflect its own colors. Since A is supposed to be cyan, red is absorbed and no light is reflected. Therefore, black is seen. B, which was magenta, is a secondary color which enables its color and the primary colors that form it to be reflected. Therefore, red is seen. We know about addition of colored lights. What about subtraction of colored lights? For colored filters, only lights of certain colors will be able to transmit through it. A primary color filter only allows light of its own color to pass through it. It absorbs the rest of the colors. For example, when white light is directed onto a red filter, only red light passes through. A secondary color filter allows its own color and the primary colors that form it to pass through. Remember this when answering questions. Now let's talk about a pinhole camera as an optical instrument. The pinhole camera experiment is a basic yet comprehensive experiment that allows us to understand the formation of images by optical instruments. Factors that affect the image's form are object distance, image distance, number and size of pinholes, and the usage of a convex lens in front of the pinhole. We must be aware of how these factors affect the image. Let's try and answer these questions. Question A. State the characteristics of the image formed in a pinhole camera. The image is real, inverted, and smaller. Question B. What is the property of light used in this experiment? This is simple. It is light traveling in a straight line. Question C. What happens to the image formed in a pinhole camera if the size of the pinhole increases? When the pinhole is made bigger, naturally more light will enter the camera, but as a result, though brighter, the image will also be blurred. Question D. How can the image in a pinhole camera become clearer? Placing a convex lens in front of the pinhole camera converges the light that's entering the camera. The image becomes sharper. Question E. If the pinhole camera has three holes, draw the images formed on the screen of the camera. Since the property of light used in this experiment is that of light traveling in a straight line, there will be as many images as there are number of holes. I hope you found this lesson useful. Good luck in your exams and see you again in the next episode of SPM Top Tutor Science.